Hello everyone and welcome to the today's session. So today we are discussing Hall effect sensor. What is Hall effect sensor? So it is a sensor which is used for sensing distance or displacement or a position of any element or a proximity of any element. So it works on the principle of Hall effect. So what is here a Hall effect? The Hall effect means what? When a current is flowing through a conductor, the charged electrons move in a straight path. The charged electron will move from negative electrons towards the positive in a straight path. What will happen if you apply another magnetic field perpendicular to this conductor? The flow of the charged electron will get disturbed, and this effect is known as Hall effect. You can see here in the Hall effect transducer, it works on the same principle. Here, the current is flowing through this conductor. An AC current is supplied to this conductor. The current will flow from negative electron towards the positive electron, and it will flow in a straight path. The electrons are moving like in a straight path here. So what will happen? Another magnetic field is applied perpendicular to this conductor. Here you can see the magnetic field B is applied perpendicular to this conductor. What will happen? The flow of the charged electrons will get disturbed now. Initially, it is moving in a straight path. Now, what will happen when you apply this magnetic field to this conductor perpendicular to this conductor? Some negative, it will move in a disturbed way. Instead of moving in a straight path, it will move like this in an arc or in a curved path like this. So the sum of the negative electrons will collected in a one side, and the positive electron will come in other side. So because of this positive and negative color electrons will come in different sides, the EMF is induced transverse to the flow of current, perpendicular or transfer direction to the flow of these charged electrons. The voltage is generated because the moving straight path, the charged electrons will disturb, and it will be collected in a positive manner in one side and negative manner in other side. So the EMF is generated. So this voltage will be generated, and this voltage is known as Hall effect voltage. You can see here this voltage is given by V equals to KH into B into I divided by T, where KH is the Hall constant, B is the magnetic field, I is the current, T is the thickness of this plate. So in this manner, though the distance or the displacement can be sensed by this any displacement of the object can be sensed. You can see here the practical application of this sensor. It is used to, and here the Hall effect is used to sense the fluid level detector in any or in a petrol tank or anywhere. So here you can see it consists of a float. At the end of the float we have a magnet. You can see here at the end of the float is we are having magnet. As the petrol or the water level or any liquid level here rises, this float will come upwards, and the if the liquid level decreases, this the float will come in downward direction. So as a result of this, the distance between this magnet and we have a Hall sensor here. Upon the float, above the float, we have one Hall sensor here, and it will be connected to the measurement, voltage measurement. So you can see here as the float, because of the water level increases, the float, the distance between this magnet and Hall sensor increases. So what will happen? So here the magnet and is the Hall sensor. As the distance between this Hall sensor and the magnet increases, the corresponding Hall voltage will be generated, and it will be measured, and it will be converted into record output, and is proportional to this Hall effect is here. It is proportional to the liquid level. As the liquid level increases, the distance between these two Hall sensor and the magnet will increases. So the more Hall voltage will be generated here, and this Hall voltage is generated is proportional to the liquid level. So in this manner, so we can measure the uh, this one position of the liquid in the tank. Okay, thank you all.